In this video, I want to take a look at how to calculate alpha, or take a look figuring out how to find alpha and then figure out a sample size for an accurate estimate. Okay, so first of all, let's talk about alpha. Alpha, if you remember, is the value or represents the total area in two tails. Okay, so area in both tails. Okay, so if I say find the 98% confidence interval, okay, well, 98% would be between, okay, your two z values. So, and here's 98%. Okay, so then how much is remaining for the tails? Okay, well, if you're saying, okay, alpha then would give us 2%, okay, or you could say 0.02. Okay, would be the area in the tails. So then when the notation says alpha over 2, all right, what are we talking about? Well, alpha over 2 is 0.01. Okay, so then as I keep typing up here, I said z of 0.01 is the z value that will give an area of 0.01 in the right tail. Okay, so if I'm out here and I'm thinking, okay, here's my tail, 0.01 in the tail. Okay, the other 0.01 would be in this tail because you got half in each one. Okay, 98 in between. All right, so that means between 0 and z is 0.49. Okay, so then if you can do a table or an inverse normal, you can find the z value to the right and left is going to give us plus or minus 2.33 for the z alpha over 2 level. Okay, well, let's see what that all has to do with anything. So it says a sample of 50 days showed that a fast food restaurant served an average of 182 customers at lunch. If the standard deviation is 8, find the 90% confidence interval. Okay, so first of all, let's think what alpha is, okay, for this case. So we want, according to this, let's do green, 90% confidence interval. Okay, so if you think about 1 minus 0.9, that leaves us with 0.10. That's alpha. Okay, so then alpha over 2 is 0.05 because you're taking 0.10 divided by 2. All right, well, if you think of your normal curve, that 0.05 is the area in one tail. Okay, 0.10 is the total of the two tails. All right, so what we need is the critical value, the z value, for a 0.05 area in that tail. We also know this to be 0.45. You can use your normal table, okay, whichever way you want to figure out z. I have 1.65 coming up for my z value. Okay, so then from there, we can do our confidence interval. We'll start with 182 minus 1.65 times 8, square root of 50. Is less than the mean, is less than 182, same sentence but a plus sign. 1.65, 8 over the square root of 50. Okay, so here we end up 180.1. It's less than the mean, less than 183.9. Okay, so we can claim that we are 90% confident that the population mean is between 180 and about 184. Okay, all right, so that's kind of the story of the alpha. All right, now let's move on down a little bit here and take a look at sample size. Okay, so how large a sample is necessary to make an accurate estimate? Okay, well, it's going to depend on, I'll put it this way, depends on like three things. All right, so it's going to depend on the maximum error of maximum error of estimate. Slow down so I can talk. Okay, It's going to depend on the standard deviation of your population. Okay, that's your sigma. Okay, and lastly, it's going to depend on the degree of confidence. Okay, all right, so as we keep reading down the page here, we pick up a formula for the minimum sample size needed for an interval estimate of the population. N, okay, is given by this handy dandy formula. Okay, so Z alpha over 2. Okay, you know what that is. We've been using that at the top of the page. Degree of confidence. Sigma is the standard deviation. E is the maximum error of estimate. Okay, if necessary, round up to a whole number. Make sure you note that. Round up to a whole number if you need to. Okay, all right, let's give this a practice. A college president asked the statistics teacher to estimate the average age of students. How large of a sample is necessary? The statistics teacher decides the estimate should be accurate within 1 year, and be 99% confident. They say the standard deviation is 3 years, okay? So what is our alpha level? Well, if it's 99% confident, then alpha is 0.01, okay? Alpha over 2, okay, Z alpha over 2 is going to give us 2.58, okay, because alpha over 2 means 0.01 divided by 2 is 0.005, okay? That's the value in one tail, remember, okay? And then the maximum error of estimate, well, that's just 1 because it goes with 1 year. Okay, so your sample size N, we're going to take 2.58 times the standard deviation is 3, divide by the error of estimate, which is 1, and then we want to square that, okay? So if you do that calculation on your calculator, you get 59.9. So we will say that 60 is going to be your sample size. Okay, and that's what we were looking for. All right, I would add your sample size formula to your formula sheet. Okay, don't forget to do that. Hopefully that was a little bit helpful on finding alpha and sample size. Enjoy your day. Thank you for watching.